So today our problem is this. So here it is given that y equals to, if y equals to x to the power n minus 1 log x, then we need to find the value of x dy dx plus 1 minus n into y. Okay. Now, as if you remember that as this function contains to the power n minus 1, so we can bring log, or else we can try to proceed with the differentiation which we usually do. Okay, like suppose if we proceed normally, like no specific case, so it can be considered as u function and log x can be considered as v function, right? So ddx of u into v, we need to do the differentiation of ddx of u into v, u function into v function. Okay, so as we know, u constant, derivative of v function plus v function constant, derivative of u function, which is x to the power n minus 1. So what would be the derivative of log x? It is 1 by x, as it is in terms of dx. I mean, with respect to x we are differentiating. Okay, plus, and what would be the differentiation of x to the power n minus 1? We know the ddx of x to the power n equals to nx to the power n minus 1. So similarly, by that formula, we can write this as the differentiation of x to the power n minus 1. Okay. Now, as you can see that what we can do here, that can we write it as, let the first part be as it is, and in the second part just look at the value of y. It is x to the power n minus 1 into log x. So if we can take a x in the denominator, that then it can be x to the power n minus 1. Okay, and log x is already here. So can I write x to the power n minus 1 log x as, instead of n minus 2 we have written n minus 1, so 1x will be at the denominator. Okay, into 1 by x into n minus 1. Okay, now what you can see that this is our y part, like y equals to x to the power n minus 1 into log x. Okay, and in the ultimate answer we have to find 1 minus n into y. Just try to figure out this. This is y we have, and we have just modified this part to get x to the power n minus 1 into log x, which is already y. And in the resultant we need to multiply it with 1 minus n. So we already have n minus 1. If we take this part in this section, I mean this right hand, from the right hand side, if we take this part into the left hand side, this will be 1 minus n, right? So from here, can we write like x to the power n minus 1 into 1 by x plus y into n minus 1, as it is y. That is why I have replaced y here, and I have written n minus 1 here and 1 by x here. So as you can see, there is a 1 by x part in this section and there is a 1 by x part in this section. So we can easily cross multiply it to the left hand side where dy dx is, right? So can we write x dy dx equals to x to the power n minus 1 y into n minus 1. Okay, now what is remaining? We have got x dy dx, and with that we need to plus 1 minus n into y. So if we take this part to the left side, then it will automatically be 1 minus n into y, because the sign will be changed. Okay, so x dy dx plus 1 minus n into y will be equals to x to the power n minus 1. Easy? Yeah, it is looking like easy, but you need to just think. You need to think and like to modify in this part, because if you do not modify this part, then you will not be able to get this expression. So always remember, when we are proceeding any problem, we also have to see what we need to find out. So accordingly, we need to modify the problem. Okay, like here we had x to the power n minus 2 and log x, and we have seen y equals to x to the power n minus 1 into log x. So what we can do, we can take 1x at the denominator. So we have x to the power n minus 1. We can bring it beside log. So we got x to the power n minus 1 into log x. So we have replaced x to the power n minus 1 log x by y. Replaced it by y, and n minus 1 as it is, and 1 by x. Right? So both the parts have 1 by x. So we have cross multiplied it to the dy dx part. So we have got the x dy dx, like we need to find it x dy dx, and from this section we already have y into n minus 1. So we know when we will be bringing y into n minus 1 from right side to left side, it will be 1 minus n into 1. So we have got the desired answer as x to the power n minus 1. I hope you have understood the problem. Okay, so let's move on to the next problem. So in this problem, we have, if x plus 4 into y equals to x, then we need to find the value of x dy dx plus y into y minus 1. Okay. Like, to simplify the problem, can we write like y equals to x divided by x plus 4? We can easily write. Okay. So if we try to find the dy dx by applying the ddx of u by v formula, as the numerator can be considered as u function and the denominator can be considered as v function. Okay, so it will be x plus 4 whole square in the denominator, and in the numerator it will be x plus 4 into ddx of x will be 1 minus x constant, ddx of x plus 4 will also be 1. Why? Because 4, the ddx of 4 will be equals to 0. So whatever be the ddx of x, the same will be for ddx of x plus 4 or whatever, x plus any constant number. Okay. So from here we can see we have x plus 4 minus x. That means plus x minus x will be cancelled out. So we have only 4 divided by x plus 4 whole square as the dy dx, right? So we need to find x dy dx plus y into y minus 1, the value of this expression. Okay. So if we multiply x with the dy dx, then it would be 4x divided by x plus 4 whole square, right? Now we have to add y into y minus 1 also. So if we write 4x divided by x plus 4 whole square in place of x dy dx, okay, and if we write the value of y as x by x plus 4, okay, as x by x plus 4 into y minus 1, that means x by x plus 4 minus 1. Fine. Now just do the normal LCM. It will be 4x divided by x plus 4 whole square plus, let's as of now keep this part as x by x plus 4, and if we do the LCM, it will be x plus 4, it will be x minus x minus 4. So minus x plus x can be cancelled out. So it will be minus 4x divided by x plus 4. So as you can see, in the first part we do not need to modify anything, as here x into minus 4. That means it will be minus 4x, and here x plus 4 and another x plus 4 in the denominator. So it will be x plus 4 whole square in the denominator. So in the numerator it will be minus 4x, and in the denominator it will be x plus 4 whole square. So as you can see, what will be the answer? It will be 0, because we have 4x divided by x plus 4 whole square and we have minus 4x divided by x plus 4 whole square. So the answer of this expression will be 0. As simple as that. So I hope you have understood this deduction. It's not at all tough. Just I have converted, just I have taken x plus 4 part in the denominator of x. So to make the y, just I did dy dx, multiplied x there, and thereafter, so x divided x will be equals to 4x divided by x plus 4 whole square. So x divided x equals to 4x divided by x plus 4 whole square. Then after plus y into y minus 1. So I have replaced in place of y as x divided by x plus 4. Okay, and in place of y minus 1, x divided by x plus 4 for y minus 1. Then just the normal calculation, you will get the answer as 0. Okay, easy to understand. So we'll move on to the next problem. So we have our next problem as, if y equals to 1 plus sin x divided by cos x, then what will be the value of cos x into dy dx? We have 4 options for this problem. Sin square x, 1 plus y, y, and none of this. So you might be thinking that it can be considered as u function and it can be considered as v function. Yes, it can be. You can proceed like this way. Like you can do the ddx of u by v and proceed with the sum. But what if I tell you that it can be solved in 2 to 3 steps only, but just by following simple trigonometrical angles? What did I mean to say? That can we write y as sec x plus tan x? I hope you have understood why I have written sec x as plus tan x, because 1 by cos x, because y equals to 1 by cos x plus sin by cos x. So 1 by cos x will be sec x and sin x by cos x will be tan x. So y can be written as sec x plus tan x. As simple as that. Okay. Now what will you do? We will be differentiating both the sides with respect to x. So we have got dy dx. What would be the value of dy dx? And so ddx of sec x means sec x tan x. If you have forgot the formula of differentiation of this trigonometrical function, then I would request you to go to the basic differentiation formula and go through by those, because you need those in every steps of differentiation. Okay, so ddx of sec x will be sec x tan x, and ddx of tan x will be sec square x. Okay, it will be sec square x. So what we need to find out as a resultant, like cos x into dy dx. So we have to multiply cos x with this dy dx. Similarly, we need to multiply cos x in this right hand side also, right? So cos x into dy dx equals to sec x into tan x into cos x, as we are multiplying cos x to the both of the sides. Okay, and here it will be sec square x into cos x. Okay, now as we know, sec x is 1 by cos x, right? Or you can say cos x is 1 by sec x. In any way, sec x and cos x can be cancelled out, because if we write sec x as 1 by cos x, keeping the tan x as it is and cos x as it is, so we can easily cancel out cos x and cos x, right? So similarly here, with the sec square x, we can write the cos x as 1 by sec x. So we can easily cancel out 1 sec x from the denominator. So we have sec x in this part and we only have tan x at this part. So can we write it as tan x plus sec x? Now see, we had y equals to sec x plus tan x, and we have cos x into dy dx as tan x plus sec x. That means same. Whatever be the tan x plus sec x and sec x plus tan x are same. So we can say that cos x into dy dx will be equals to actually y, because tan x plus sec x means, as we know, sec x plus tan x, because a plus b equals to b plus a. So we can definitely write that. So cos x into dy dx will be equals to y. So it matches with the option C. So C will be our correct option. Okay. Just see how easily the problem can be deduced. You do not need to do the ddx of u by v for this problem. Just try to simplify the problem as far as you can. What I did 1 by cos x equals to sec x plus sin x by cos x equals to tan x. Just differentiated both the sides, then just multiplied cos x to the dy dx and to this side and just simplified. So your answer will be y. So it matches with the option C. Okay. So let's move on to the next problem now. Okay. Now we'll try to solve this problem. Okay. Here it is given that if y equals to 2x tan inverse x minus log of 1 plus x square, then dy dx will be coming in this format, k into tan inverse x. So it is already given to the problem. So we need to find the value of k, okay, according to this condition. So what best we can do, we can try solving the dy dx first. For that, we need to differentiate this expression, both the sides of this expression with respect to x. So let us do that at first and see whether we are getting this kind of format or not, right? So if we differentiate y, it will be dy dx, right? So let's keep the 2x part as it is. So segment this as two different functions. Okay. So again, 2x and tan inverse x can be considered as two separate functions. So I am considering 2x as u and tan inverse x as v. Okay. So we can easily apply ddx of u into v formula. So according to that formula, u constant, ddx of tan inverse x. So derivative of tan inverse x is 1 by 1 plus x square. Okay. Plus now we need to take tan inverse x as constant and derivative of 2x is 2. Okay. Now minus, now we need to differentiate log of 1 plus x square. So we know log x, the differentiation of log x is 1 by x. So the differentiation of log of 1 plus x square will be 1 by 1 plus x square at first. Then we need to again differentiate this section. If it would have only x, then we can easily write 1 by x only. But instead of x, whatever be the term here, we need to again differentiate it. So the differentiation of 1 plus x square would be only 2x. Why? Because the differentiation of 1 is 0 and the differentiation of x square is 2x as per the formula ddx of x to the power n, where we get x to the power n minus 1, right? So as you can see, here we have 2x divided by 1 plus x square and we have minus 2x divided by 1 plus x square. And apart from that, we have 2 tan inverse x. So we can easily cancel out this two part. So what we have 2 tan inverse x, and as you can see what they are provided in the problem, that dy dx will be k into tan inverse x. So we have dy dx as 2 into tan inverse x because these portions got cancelled out, right? So we have 2 tan inverse x. So k equals to 2. Okay. So this is the value of k. So as you can see, we have solved the problem in merely 3 steps. Okay. What I did, I considered this two part as separate segments. In 2x tan inverse x, we have considered 2x as u function, tan inverse x as v function. And did the differentiation, and for log of 1 plus x square I did the differentiation, right? But as you can see here, it is 2x divided by 1 plus x square, and it is minus 2x divided by 1 plus x square. So we cancelled out this two parts. So what we had 2 tan inverse x, and that matches with the form k tan inverse x. So we can say the value of k will be 2. Easy. So we'll move on to the next problem now. So we have another problem where we need to find the value of k again. Okay. So it is given that if y equals to log of log ex, then dy dx equals to k by log x to the base e. So they have already given in the problem that dy dx will be coming in this way, like k divided by log e to the base x. I mean log x to the base e. Sorry. So we need to find the value of k, right? So the best we can do, like we can differentiate y equals to log of log x with respect to x. That means I need to differentiate both the sides of this expression with respect to x. Okay. So if we try to differentiate both the sides with respect to x, then what we will be getting? Like log of x, just for an instance consider it as capital X. So what would be the derivative of log x? It would be 1 by capital X, and capital X means log ex. Right? Now if it is only x, then the differentiation of log x would have been 1 by x only. But here instead of x we have log x again. That means we need to differentiate the log x again. Now we can write 1 by x. Did you understand that part? I am just repeating once. Here we are differentiating log of log x. So I am considering this log x part as capital X. So y of log x, so differentiate of log x would be 1 by capital X, and instead of capital X we are replacing log x to the base e. So as we know, we need to again differentiate this log x to the base e, and differentiation of log x to the base e is 1 by x, right? So we have got in this form just as one line problem this is. Okay, so it can be written as 1 by x log x. So just compare this part with the form they have given in the question, right? So here log x in the denominator, log x in the denominator. So what would be the value of k? As we can understand, the value of k will be 1 by x. So it's a very simple problem. Just by the basic differentiation you can find the value of k for this problem, right? So k will be equals to 1 by x, and this is the answer for this problem. Okay, so we'll move on to the next video now. So you can like the video and subscribe to my channel so that whenever I upload any new video, you get the notification and it might help you. Okay, so you can consider my mathematics tutorial is ideal for anyone who is from standard 8, 9, 10 to the higher secondary standard, I mean 10 plus 2 standard, up to the graduation level, and you can consider this kind of problems for any kind of competitive exams. Like if you are sitting for the joint entrance examination, so you can consider these videos helpful, because I have tried to make the playlist from the simple problems to the advanced level problems for any of the topics. Like I am covering differentiation, I have covered logarithm, and there are several topics which I have covered already, right? So you just go step by step to the playlist. You get to understand how I have arranged the playlist so that one who is not expert in mathematics but have an energy to understand the mathematics, have a grudge to understand mathematics from the good concept. Okay, so it will be helpful for them. Okay, just go by step. If you are finding any problem hard, or if you're finding that no, I'm not understanding this problem from the video, you can always ask me. I will try to explain you as easy as I can. Okay, so we'll move on to the next problem now. Okay.